Oh, hello everyone. I'm Gary Williams. This is Ramblings of a Sysadmin. I've got a cup of tea, I've got a lab, and today I'm going to be rambling about iSCSI, so I hope you enjoy this. In order to get ESXi talking to FreeNAS using the iSCSI protocol, there's a couple of things I need to check. Now, the first thing is I need to make sure that the iSCSI protocol is running. And as you can see here, it's stopped. So what I'm going to do is start that. It will start fairly quickly. Tick the start automatically box. So all this is going to do is it will restart the iSCSI service if I have to reboot the box for any reason. Now, when I do this, down the bottom here I have the messages up just so I can get a brief view of what's going on. Obviously the logs are a lot longer than this. This just shows the last few lines. I can see a couple of LUN creation warnings. This is because I've deleted this area. This was some other work that I was doing, so this is absolutely fine. There's no errors related to iSCSI itself, so I know iSCSI is working, the protocol has started, everything is good. The next thing I need to do, I need to actually create the LUN where ESXi is going to connect. The best way to think about a LUN is that it is just this block of storage that the SAN gives to a device and says, do what you want to it. That LUN can be a NTFS area if it's talking to Windows. It could be FAT16 if you really wanted. The SAN doesn't care. It just says, block of storage, do what you want. Because we're going to be connecting this to VMware, the format will of course be VMFS. So the SAN itself, as I say, just doesn't care. It just says, here's a block of storage. NASs are different. What a NAS will do is you talk to the NAS using a protocol, NFS and RSMB. Now, there's also AFP, but let's not even talk about that. And what happens is, once that data is across to the NAS itself will write to the disk. And the disk, in the case of FreeNAS here, the underlying disk format is ZFS. Now, Windows, VMware, all that cannot talk natively to ZFS. So effectively, the NAS is acting as a translator. It receives the data from VMware, in this case over NFS, and it will write down to ZFS. Might seem a bit confusing, but once you understand the difference between a file protocol and the underlying disk format, it does become a lot easier. Right, let's get this LUN created. So what I need to do is storage pools. I call my main pool storage. If I click over here, I can add a data set. So in this case, we'll call this VMware. Really don't care about any of these options. I'm going to be creating a LUN, it's irrelevant. I'm going to save that. Great. Right, so I've now got my data set. What I need to do is actually go back to my services, back to iSCSI and configure. Now what you'll see across the top is basically a lot of things we need to go through to make sure that the iSCSI target is set up properly. Something that's really important to know is the difference between the initiator and the target. In this case, my SAN is my target, VMware is the initiator. So if you think about it as almost source destination, VMware is the source, the SAN is the destination. This is where I'm trying to connect to. So target global configuration, we have the IQN, which is the base name. I have no need to change this. I will leave that as it is. I will see this in VMware. We can use ISNS servers. This is the iSCSI naming service. To be honest, I've been using iSCSI for some years now. I've never known anyone to use these. I've never even configured one of these servers. So we'll just ignore that. Pool available space threshold, I don't need to worry about that. This is only going to be a small LUN just to demonstrate the concept. Over on portals, what I've got is I've actually got two NICs in this device. And I've got two IPs. Now, if you have a look, you will notice that this is 10.252.1.1. This is 10.252.2.1. The reason these are different IPs is they're different physical NICs, but they're also on different networks. I call one SAN1 and one SAN2, and I really should sort out my case and make sure they're all the same, but that's a minor detail. The best practice with iSCSI is to make sure that you've got two different IP ranges, at least two different IP ranges I should say. So you'd have one on one NIC, one on another NIC. The reason being is this gives you MPIO. And what that means is you have two paths. You can take a path down to do some work, say on the management head of a SAN, or you could dislodge a cable accidentally, and MPIO will kick in, make sure that your connection to the LUN is still there and everything is good. So best practice is to always have two NICs dedicated for iSCSI, because iSCSI is going to use the full bandwidth if it can. So it's best to not mix it in with any other front-end traffic, management traffic, things like that. So on this device, I've actually got two NICs and I've got two different IP ranges. If I was doing this in production, they'd go off to two different switches, which would go off to servers and different NICs on the servers and so on and so forth. You'll notice here it's :3260. Now by default, the port for iSCSI is 3260. Over to initiators. Now initiators, as I said earlier, that's my source. That's going to be VMware. So why does the SAN need an initiator? Well, what this does is this actually has certain initiators, and we'll be putting the IQN in here, and we can say it comes from certain networks. This is a really nice way of saying, hang on, only that IP can connect to this LUN. Now this is kind of important for doing your LUN separations with, especially with Windows, because you don't want to have, say, 3 different Windows servers all seeing all the LUNs that's on the device. Windows is not the best file system for this kind of thing. It is not cluster aware. So if you have 2 Windows servers talking to the same LUN and they are not running Windows clustering services, that LUN will be online on both servers and it will be instantly corrupted. You don't have to make any changes to it. Just connecting will corrupt it. So be very, very careful. VMware, you don't have to be so careful. It is cluster aware. It's designed to be cluster aware. So we can have multiple hosts talking to the same LUN with absolutely no issues. So in this case, for the initiators, I'm actually just going to leave this as is. There's no need to change this because I'm just going to have VMware talking to it. Authorized access. I'm not actually going to be using this, but I am going to be just quickly showing you how this works. On a lot of devices, this is also known as CHAP, the Challenge Handshake Authentication Protocol. So I can say this particular group ID, this user, this secret, and put in the peer user, peer secret from the device itself, and set up a, I don't want to say encryption because it isn't, it is almost like password protected. I've never used this. I did have someone say to me that they actually use this, but not for security. They use it as an additional method of making sure that a device is talking to the right LUN. So each LUN, the way they configured it is that each LUN had its own CHAP password, and it was just that additional layer saying, I know what LUNs I'm talking to. I've never done that. I actually thought that was a really good idea. I might start doing that in the future, but for this setup, but for this demo, I'm not going to do that. So I'm just going to cancel out of this. I just wanted to show you what it looked like. Targets. So a target is the 2 NICs. So as we can see here, Store 07, which is the name of the storage array, SAN1 NIC and SAN2 NIC. If I edit one of these, you can see here I can actually say I only want certain initiators connecting. It needs to have this auth method or this auth group. So you can really make this granular. But because I've only got the 2 NICs, and I'm not going to be saying this ESXi host will use these NICs, this ESXi host will use different NICs, I'm just going to be using these 2 NICs from all the hosts. Okay, extents. So an extent is the actual LUN. Now I've heard it called many different things. I've heard it called volumes if you're on IBM SANs. I've heard it called extents. I've heard it called LUNs. Technically it is an extent, but the names are kind of used interchangeably these days. FreeNAS calls it an extent, so that's fine. I need to give it a name, in this case VMware iSCSI. This name doesn't really mean anything, it's just there as a label on the host itself. I'll be selecting file because I'm going to be connecting it to a file that's going to be on the host. Device means a physical device attached to the host. I'm not going to be doing that. In fact, I've never done that. It's always been a file sitting on the SAN itself. I need to give it a path. So I'm just going to drill down to the area I created earlier, which is this VMware area. I'm going to throw a name on the end, VMware iSCSI.lun. The reason I'm adding .lun on the end is just so that I can find it if I need to look at the raw file system for whatever reason. I know that is my lun, or my extent. I should probably call it .extent in this case, but old habits die hard. The extent size is how big I want to create it. So in this case, we'll just create it as 100 gig. Don't really need anything bigger than that for this test. Logical block size, I'm going to set to 1024 because that's the size that VMware will use by default. Do be careful with logical block sizes. If I take a look at this disable physical block size reporting, you'll see here it starts to say, oh, be careful with Microsoft SQL, and that's very true. SQL can be quite a pain with its block sizes. If you pick the wrong block size, you can get performance hits. The larger block sizes generally work better with SQL, but you need to speak to DBAs to find out what they think would be best. But I say generally, because SQL databases are quite large, much like VMware disks, because don't forget we're going to be using this to put a VM in there, so it's going to be the VM files with its VMDX files and all that sort of stuff. It allows for more data to be transferred in one go than you would normally see, or certainly you will see with a smaller block size. So as the block size by default is 1024, everything should be aligned and it should all just work. Enable TPC, I'm going to be honest, I don't know anything about this. It's not something I've seen on other devices. I don't even know what TPC stands for. In this case, the help here says it allows certain types of bypass or Xcopy operations. We're not going to be using Xcopy because it's going to be VMware. So I'm going to leave that on because it's on by default. I don't think it's anything we need to worry about. Zen initiator compat mode, it's not a Zen host, it's VMware, so I'll leave that unchecked. The RPM is an interesting one. We can actually lie to the host and say I'm really an SSD when I'm not. There are certain devices that might need a certain RPM speed, so you can cheat and lie to it. I've never ever seen one that does, but the option's there. The last two options, read-only and enabled, pretty self-explanatory. I do need the LUN enabled. I don't want it to be read-only. I'm going to have to format it, so read-only would be kind of pointless. Now it could be argued there are use cases for read-only. For example, if you've got a LUN that you've had connected to a device and you need to present it somewhere else. Again, watch out if it's Windows, don't have it on two hosts at the same time, it will corrupt. But you could detach from one host, attach to another. Okay, so let's take a look at the VMware side. Now what you can see here is I'm on my ESXi host here, VMware e1.gdwnet.com. It's running the hypervisor ESXi 6.7. Now up here you might notice this is VCentre 6.5. This is a DNS holdover, it's actually 6.7. It will be getting fixed, so just ignore that. But you can see here as well, I've got several boxes that are off. This is lab, so I do turn boxes off to save power and save the electricity bill, which is why it's like this. Obviously in a production environment, this should be a little bit neater. But this is just a lab environment. So what I'm going to do is I'm going to take this host and I'm going to add iSCSI to it. Now, if I go over to configure and I go over to my storage adapters, we can see the storage adapters that are in this host. And it might be worth a quick look just through these storage adapters. So what you will see here is SATA IDE controller, which are block iSCSI devices. I'm not actually sure what these are. I suspect this is like the DVD drive in the system, possibly a USB hub or something like that. I'm really not sure. This PERC H700, this SCSI HBA, in case you're wondering, HBA stands for Hardware Bus Adapter. This is the PERC card, so this is what talks to the disks inside the server itself. And finally, we've got these two fiber channel cards. Now, both these fiber channel cards are offline. I don't actually use them in this server at this time. It was for a project I was planning on doing, never got around to. But some servers will have hardware iSCSI adapters. This one doesn't. So how do I do iSCSI on a server that doesn't have a iSCSI adapter? That's where the magic of this software adapter comes in. You can add a software iSCSI or FCOE. FCOE is fiber channel over Ethernet. So I add this, add a new software iSCSI adapter. So interestingly enough, the FCOE adapter is grayed out because it does need a physical adapter to sit on top of. Even though it's a software adapter, it still needs a physical adapter. The software iSCSI adapter can quite happily sit on top of the installed NICs in the host. So that's why that's there and available. So I hit that. VMware will take a few seconds to do its thing. And once the box is refreshed, we've got a new HBA. We've got this iSCSI software adapter. And you can see here this IQN. Now this is going to come in useful. So I'm going to need to make a note of this. Best way to do that, copy paste and chuck it on Notepad, or Notepad++, which is definitely the better Notepad. So taking a look at the physical adapters, I can see I've got 4 physical adapters in here. I've got one that's up, that's my management. That's going to be my front end traffic where all my users' VMs are. And I've got 3 that are down. Now, again, this is a lab box, so this is fine. In the real world, you'd really want to get as many of your NICs up and running as possible and put them all into some sort of virtual port ID, which is basically a cheap but really quite reliable way of doing load balancing of the VMs. There are better if you've got enterprise licensing, LACP and all that. Probably something for another video, but there are options out there. Because this is a lab box, I've got just this one NIC plugged in. It just saves me on the cabling and keeps the lab tidy. As I want to give iSCSI to the ESXi host itself, what I need to do is configure the networking, and I need to add 2 VM kernels onto this machine that will carry the iSCSI traffic. Now it is going to go with the same vSwitch, but it is going to need an IP address on each network that I've set up for iSCSI. So I need 2 of these VM kernel adapters. So what I need to do is add a VM kernel network adapter, select an existing vSwitch, give it a label. So in this case, I'm going to call it iSCSI Network 1, VLAN ID 2521. Everything else I'll leave as default. I'm not going to mess around with the MTU because I'm going to be mixing and matching internal and iSCSI traffic. Also, I found setting the MTU to 9000 can sometimes be a bit hit and miss. In this case, I'm just going to leave it alone. Need to set a static IPv4 address. For all my ESXi hosts, I have reserved IP addresses for their iSCSI networks in my IPAM tool. So in this case, it's 10.252.1.11. Subnet mask is going to be that, which is just a /24. DNS servers, I don't care about DNS because I'm not going to be doing DNS on this network. It's all going to be pure layer 2. And done. And there it is. Okay, there are my 2 iSCSI adapters. So what this means is I have 2 paths down to my storage. My storage has 2 paths. This allows me to use MPIO to balance the traffic, and if there's a problem on the path, a link goes down or something like that, traffic will keep on running. Jump over to FreeNAS. Now FreeNAS has a very nice shell option down here. Here we go. So I can test my connectivity from FreeNAS to my ESXi host. So all I need to do, standard ping test. That's my first iSCSI NIC, and 2.11 being my second. And what I need to do is go back to my services, iSCSI, associated targets, and I need to associate the iSCSI NIC with the extent. So I'm also going to give this a LUN ID of 10. Now this is something I've been doing for years. The reason I start my LUN ID numbering at 10, it's something I've always done, is simply because LUNs that are in the system, like your iSCSI disks that are local to the system, tend to start with LUN ID 0. This means that anything that's above 10 or above is almost certainly going to be remote. There's other ways to check as well, but this is just something I've always done, just for that additional verification that this is a remote iSCSI or fiber channel LUN, and I know what I'm looking at. So let's save that. You may notice that I've only allocated one SAN NIC. I should allocate two, but I'm just going to do this one just to make sure I've got connectivity from the ESXi box down to the storage, just to make sure everything is working. On the ESXi host, I need to tell ESXi where the SAN is. Now the way I do this is under storage adapters, click on the iSCSI adapter, dynamic discovery, add the iSCSI server's IP address. So in this case, my IP address is going to be this 10.252.1.1. So I'm going to add that in, 10.252.1.1. Note the port is 3260. We OK that. Due to recent configuration changes, a rescan of VMHBA65 is recommended. So we can see they've got the exclamation mark, that's our iSCSI. Whenever you make a change to iSCSI, always do a rescan, it will save your sanity. So we let that go through and do its stuff. Once that's complete, we should be able to add in our new data store, or we should be able to add in our new disk and then format it as a data store. So to do that, actions, storage, new data store, VMFS. There it is. We can even see our LUN ID. So everything there is good. It thinks it's flash because we configured it and gave it the RPM of a SSD. I'll leave the data store name alone. Obviously in production you'll give it a better name than that. VMFS6. Use all available partitions. It hasn't got any full size 100 gig. Yep, that's all fine. And finish. And as you can see, we've now got our data store here. This ID here, this NAA, this ID here, 6589 blah de blah de blah, 6589 blah de blah de blah. So yeah, that looks good. That's the one we want. When I did the dynamic discovery, I only put in one IP address. I do need to add in the second IP address. Now I have cheated and I've already associated it with the second NIC. So let's just add in the next IP, 10.252.2.1. We do another rescan. And if I now come over to paths, as you can see, I have multiple paths in here. We've got two paths coming from SAN 1 NIC and two paths from SAN 2. You'll notice here that one is active I/O, the others are just active. The reason for this is that FreeNAS is quite a simple SAN. Your commercial SANs like your NetApp and your IBM may well have two active paths. Certain other storage arrays, like your real high-speed storage arrays, will have four active paths or potentially more. So don't be surprised if it looks slightly different, but you should always have at least one active I/O. And if we were to lose this path, another NIC would be picked, or another path would be picked to go active. That's how the whole MPIO works, and that's why it's important to have multiple paths down from your ESXi host down to your storage. The last thing to show, and I have just made this change under initiators, is if you remember, I said do remember or do make a note of this IQN, this thing here. One of the things that we can do is we can say, rather than allowing all initiators, we just allow those IQNs. With FreeNAS, there doesn't seem to be a way to say this IQN can see this LUN. Other commercial storage adapters, again your NetApps, your IBMs, do allow that. They allow the granularity to say that IQN can see that set of LUNs but not those LUNs. This is kind of important when you've got multiple LUNs, like you've got your VMware LUNs, your Windows LUNs, so on and so forth. It just adds that additional protection to make sure that your ESXi host can't accidentally format a Windows LUN. Yeah, it's kind of important when you're working in those types of environments. Anyway, I think this has probably gone on for long enough. I've probably bored everyone by now, but if you have stuck with me through this, I really hope this has been useful. So I'm going to end it there. Thank you very much for your time. Please like, comment and subscribe. Cheers.